In this example, we will have a look at comparing two sample population proportions. So when we come back to the polling problem of the newspaper who was searching for agreement with the statement, the city mayor is doing a good job. So the local newspaper is also interested in how a person's support for this statement may depend upon their age. Therefore, the pollsters also gather information on the ages of the respondents in the random sample. And the problem is, does the strength of support for the statement differ between the two age groups? So now if we look at more data from this sampling, so we have the whole population, but it is split by age. We have one group aged 18 to 39, and then others aged 40 plus. Now the two samples were a bit different. The total sample size for the younger people was 952, the older people 1043. They were all asked the same questions, and then there were some results from that poll. So we had 0.66 almost proportion of younger people agreeing with the statement and 0.4 of the older people. And we would like to test, are these two population proportions significantly different or are they the same? So of course, the null hypothesis for the test can only be one. We say that population A proportion equals population B versus the alternative that's not the case. So PA is not PB. We have all the numbers given, and so we have to calculate the pooled estimate for the proportion. So the formula was x plus y divided by n plus m. In our case, when we put in the numbers, 627 plus 421 divided by 952 plus 1043, this gives us 0.525. Now the test statistic was the difference between the individual proportions divided by that pooled estimate standard error. So we had p, 1 minus p, and times 1 over n plus 1 over m. So there is no magic in here other than putting in the numbers, and the result here is 11.39. Now once again, if you've worked long enough with the distributions, you will know that this is a very high statistic value, so it should be way beyond any critical values. But just for formality, if we take confidence interval of 99%, so alpha is 0.01, and that means that the Z statistic, the critical value, will be once again read from the tables or taken from MATLAB with the norm in function 2.5758. Now this is the critical value, and it is certainly less than our Z value, which is this 11.39. So our Z value is beyond the critical region, which means that we reject the null hypothesis. There is very, very strong evidence to reject null hypothesis. That is, there is enough evidence that there is a difference in opinion between the groups, so that there is influence of the age on the opinion on how the city mayor is performing.